S1 equal to 0, S2 equal to -1, S3 equal to -5. Okay, these are the poles. Okay, zeros are S1 equal to -1.5. Okay, so P1 equal to 0, P2 equal to -1, P3 equal to -5, and Z1 equal to -1.5. Okay, so on the S plane you can locate zeros and poles. Okay, so there are three poles are there. If you observe here, there are no complex poles. Okay, till now we have solved problems in which we complex poles were there. In this problem, complex poles are not there. All the poles are real poles. Okay, of course all are not positive. This is a zero is also a real zero. Okay, it's not complex. Okay, so on the S plane if you want to look at, so I have considered 2 centimeters equal to 1 unit. I hope you are taking the screenshot, all of you. You are taking the screenshot. Okay, don't wait. As soon as I change the slide, immediately take the screenshot. Okay, if you miss, inform me. If you miss to take the screenshot, you just inform me. Okay, and submit the homework daily till all these problems are completed. Till then you submit the homework daily. So P1 is 0, P2 is -1, P3 is -5. So I have taken 2 centimeter equal to 1 unit. Okay, so 2 centimeter equal to 1, 2 centimeter equal to 1. Okay, so this is my scale for both x-axis and y-axis, uniform scale. Okay, 0 is -1.5. So this is my 0. These are my poles. If you observe, all the poles are lying, all the poles and zeros are lying on the real axis. Okay, there is no complex pole. So step number 2 is what? To find the root locus on the real axis. Okay, step number 2 is to find the root locus. See, I have written all the story, but you write in a short form. Okay, you people write in a short form. So see, you simply write that, I will tell you what to write. Consider a test point, okay, on the left of the pole P1. Okay, and look towards the right side. When we look towards the on the right side of the test point, okay, so there the sum of poles and zeros is equal to 1. Okay, so which is an odd number, hence root locus will lie from this pole P1 to pole P2. Okay, I hope I don't know whether I have written here. Here I have not written P1, P2. I have written all S terms here. Okay, so I hope you have taken the screenshot. Okay, so I opened this slide and I was speaking something so that you can take the screenshot of this slide. Okay, so in order to give you time to take the screenshot of this slide, I was speaking. Okay, now, so you just consider a test point. Okay, on the left of this pole. Okay, and look at the right side. You can see the sum of poles and zeros on the right side of this test point is 1, which is an odd number. So root locus will lie from on the left side of this pole till it meets any pole or 0. There is a pole P2 here. So from here to here, there is a root locus. Okay, you have to draw a thick line here. Okay, now consider a test point after P2 on the left side of P2. Okay, so I have considered a test point on the left side of P2. From there, I am looking towards the right side. When I look towards the right side, the sum of poles and zeros on the right side on the real axis is 2. Okay, sum of poles and zeros. Of course, there are no zeros, but in general, I am talking. The sum of poles and zeros on the right side are 2, which is an even number. So root locus will not lie between P2 and Z1. Okay, root locus will not lie between P2 and Z1. Now consider a test point on the left of Z1. Okay, so consider a test point on the left of Z1 and look towards the right side. When you look towards the right side on the real axis, the sum of poles and zeros is equal to 3, which is an odd number. Therefore, root locus will lie from this Z1 to till it meets any other pole and 0. There is a pole here. So you draw a thick line from Z1 to P3. Okay. Okay, now consider a test point on the left of this P3. Okay, from here look towards the right side. The sum of poles and zeros are total is 4, which is an even number. So no root locus will lie on the left side of P3. Okay, so the till now we have got 2 root locus. One is in between P1 to P2, Other one is Z1 to P3. Okay. So if you have understood the concept, you will write in step number 2, you will write the theory on your own. Okay. So see, this is the next slide. Take the screenshot of this. So you see, this is a pole, this is a zero. Root locus has started from the pole and ended at the zero, isn't it? Root locus will always start from the pole and it will end at the zero. So you can mention the arrow mark. I have not drawn the arrow here. You can draw the arrow towards the zero, from pole towards the zero. The one root locus path is completed here, you can observe. Okay. One root locus path is completed. Total 3 poles are there, 3 root locuses must be there. Okay, so already one root locus path is completed, started from pole and ended at zero. Okay, so two more root locus, two more poles are there. You have to plot 2 more root locus, and we have only 1 0. We need 2 more zeros. Those 2 zeros will lie at infinity. Okay, I hope you have taken the screenshot. I'm moving to the next slide. Okay. Okay, next step is to find the angles of the asymptotes and the centroid. So there are 3 poles are there. You will have 3 asymptotes. One asymptote will you already have plotted a root locus on the real axis. So one asymptote will lie on the real axis here, parallel to this root locus. Okay, so that asymptote no need to plot. So we need to plot 2 more root locus here. I'm sorry, 2 more asymptotes. You have to determine 2 more asymptotes. Okay, these two, and you also have to determine the angle of these two asymptotes. So you know this familiar formula to you, that is 180 into 2q plus 1 by n minus m. What is n? Number of poles are 3. Number of zeros, m is 1. So 3 minus 1, it is 2. So q is equal to 0, 1, 2. Okay, n is 3, m equal to 1. So q equal to 0, 1, 2. So for q equal to 0, angle is plus or minus 90. Okay, for q equal to 1, angle is, you will get 270 degree, just subtract 360, you will get this. Okay, above 180 means you have to subtract that value. Okay, 360 from that value. Okay, so if it is above 180, that you must remember. Okay, for q equal to 2, determine the angle. So you have got 90 degree, plus or minus or plus 90 degree you have got. Okay, centroid is what? Sum of the poles minus sum of the zeros. What are all the poles? 0, 1, 0, minus 1, minus 5. Minus of minus 1.5 is your 0. This is your 0. This is your, these 3 are your poles. So n is 3, m is 1. Okay, so you just simplify it, you will get minus 2.25. Okay, so centroid is lying on the negative real axis. Okay, centroid is lying on the negative real axis at minus 2.25. Okay, so let us see. I hope you have taken the screenshot of this slide. Did you take the screenshot of this slide? So I wanted to complete at least 2 problems today. Each class, if I am able to complete 2 problems, it will be easy for me to. We have to complete. We have to go to further units also. It's a problematic subject. I hope you have taken the screenshot of that slide, and you have taken the screenshot of this slide also. While I was discussing about these angles, you might have taken. Okay, I'm moving to the next slide. Okay, so you can see centroid is at minus 2.25. This is it. Okay, so at this minus 2.25, you have to asymptotic angles are plus or minus 90 degrees. So at 90 degree, draw the asymptotes. Asymptote will always start from the centroid, that you already know. Okay, so this is it. Okay, take the screenshot of this. I hope you have completed. Okay, I hope you have completed. I'm going to the next slide. Okay, So you have to determine the breakaway and break-in point in step number 4. Okay, so you must write these steps for in these problems. You must write each and every step. Okay, so our open loop transfer function is given, and this feedback is unity feedback. So whatever transfer function is given, okay, substitute here in this closed loop transfer function formula and simplify it. You will get this expression. Okay, so whatever denominator is there, you just equate it to 0. That is your characteristic equation. Determine k value, okay, expression for k from this characteristic equation. Okay, so from this characteristic equation, determine expression for k. So you will get this. Take the screenshot. I hope you have taken. I'm changing this slide. Okay, I'm changing this slide. Okay, you have got an expression for k here. Okay, now differentiate this k by s. You will get this expression and equate it to 0. Okay, differentiating whatever equation that you have got for k, you just differentiate it with s and equate it to 0. You will get this expression. Okay, after equating it to 0, you just further simplify it. Okay, so you will get s plus 0.6 into a quadratic equation s square plus 4.65 s plus 6.2 equal to 0. So this is a quadratic equation. You can determine the roots for this equation. And s plus 0.6 means s equal to minus 0.6. Okay, so you have got the s values here. Okay, so s equal to minus 0.6, s equal to minus 2.3 plus or minus j of 0.86. Okay, take the screenshot of this. So in order to determine breakaway and break-in point, what you have to do is you have to determine the closed loop transfer function. Okay, and equate the denominator to the 0. That will be your characteristic equation. From the characteristic equation, determine an expression for k, differentiate k with s and equate it to 0, and further simplify it and determine some values for s. Okay, so whatever values that you have got for s, let us check whether k is real and positive or not. That's our aim. Okay, for s equal to minus 0.6, okay, you have got an k. You substitute this s value in the expression of k. What's your expression for k? This is your expression, isn't it, for k? What is this? Wait 1 minute. I have written instead of copying this term, okay, instead of this is our k, isn't it? I have copied another expression there. So Control C. Okay, I don't know why I have done that. What is my slide? Is this delete equal to Control V. It is not pasted. Control V. It is not copied. It seems. Wait, once again I will try to copy. No. Yeah. Where is it? I want the k value. Yeah. Something is wrong with my system. It is not responding. Okay. Okay, control C and control V. It is copying here instead of here. Okay, so wait, I'll make some modifications here. I hope this is okay. Now take the screenshot, Amma. Earlier, the equation, I have copied wrong equation here. Okay, instead of k equation, I have copied the equation after differentiating and equating it to 0. Okay, so substitute the value of a breakaway point. Okay, s equal to minus 0.6 is a breakaway point. Okay, so when s is equal to, so k, if you get k real and positive, that means whatever s value is there, that is your breakaway point. So for s equal to minus 2.3 plus 7 j of 0.6, I have not shown the simplification here. Okay, if you want, you solve it and you will observe, you will get you will see that k is not positive and real. Okay, I have not solved here because I know the answer, that's why I didn't solve here. Okay, k is not real and positive, so that you can, so this s value is not the actual breakaway point. Okay, you know how to simplify. In the previous problem itself we have simplified it. Okay, so of course not in the previous one, in this problem also you can do it. Okay, so it's not a big issue, you do it. Okay, so k is not real and positive, so s value is not the actual breakaway point. So we have got one breakaway point here, that is s equal to minus 0.6. Okay, why s is equal to minus 0.6 is the breakaway point? Why? Because the value of k, when you substitute s value in the k expression, the value of k is real and positive. Okay, so value of k is real and positive, that's why this is the actual breakaway point. Okay, so go to the, now mention this breakaway point on this slide. So it is minus 0.6, you just see. You take this snapshot, screenshot of this. Okay, I hope you have taken the screenshot, breakaway point. Okay, next is to find the angle of departure. Okay, so do you have any complex poles here? There is no complex poles here, so there is no need to determine the angle of departure. Okay, that you must remember. So if there are no complex poles in the given open loop, for the means if you won't get any complex poles for the given open loop transfer function, there is no need to determine the angle of departure. Okay. Okay. Yeah. Okay. That's good. Okay. So no need to determine the angle of departure for this. For the remaining two poles for which you have to plot the root locus. Okay, because they are not the complex poles. Okay, now let us determine the crossing point on the imaginary axis. Okay, so you know the characteristic equation already. For in order to determine breakaway and break-in point, you have determined the characteristic equation for the closed loop system. Okay, so take the characteristic equation, you further simplify it. Okay, and substitute s equal to j omega. Okay, when you substitute s equal to j omega, yeah, this will be your expression. Okay, you further after substituting s equal to j omega, you further simplify it. Okay, simplification will be only with respect to this j value, j square, j cube and all. Okay, so you will get this expression. Take the screenshot of this. Take the screenshot of this. Okay, I hope you have taken the screenshot of this. I'll move to the next PPT. Okay, now whatever imaginary terms are there, equate them to 0, and real terms are there, equate them to 0. So what are all the imaginary terms here? Imaginary are, this is imaginary, minus omega cube plus 5 omega plus k omega are the imaginary. Minus omega cube plus 5 omega plus k omega. Okay, equate them to 0 and you will get an expression for omega square. Okay, you can even write omega equal to root of 5 plus k. You can write that. Okay. Okay, so even if you write that, it doesn't matter. It's not going to change anything. Okay, if you want, you can write that. What are all the real terms here? Minus 6 omega square plus 1.5k. Okay, so minus 6 omega square plus 1.5k is your real. So equate it to 0 and simplify it. You will get omega square to 5 plus k. Okay, so here omega square equal to 5 plus k. Sorry. Sorry. Yeah. Sorry, I didn't read this put. Okay. So you just, of course, for the only two terms are there. Only two terms are there. That too, they both are different terms. This is omega, this is k. So nothing is there to simplify here in this expression. Okay. So simply, you just substitute this omega square value in this expression. Okay, when you substitute this omega square in this expression, you will get k equal to minus 0. Minus 6.67. Okay, k, you will get k is equal to minus 6.67. Here k is negative. Okay, so k value is negative. Therefore, there is no crossing point on the imaginary axis. Okay, so disconnected. No, okay. So I was even though I was disconnected, I will be continuously teaching. Huh? So we already know there is a root locus between these two poles. Okay, so there is no crossing point on the imaginary axis. So definitely this root locus will not pass through the imaginary axis. Okay, pass through any point of the imaginary. There is no angle of departure. So now you have already determined that. I think you have not taken the screenshot of this slide. You take the screenshot of this slide. Okay, take the screenshot of this slide. Whatever on this slide, I'm explaining it, showing you the graph. I hope you have taken. I'm shifting to the graph in order to explain the root locus. Okay, now, so we already know there is a root locus between these two, and this is the breaking point. So from the breaking point, root locus from any of these two poles will move towards the asymptote. So asymptote is there, it will move towards the asymptote and try to travel parallel to the asymptote to meet the zero at infinity. Okay, another root locus will try to move towards the asymptote and try to travel parallel to the asymptote to meet the zero at infinity. Okay, so total 3 root locus. This is one root locus from P3 to Z1. Another root locus is from P1 to maybe in that direction or the other direction. Okay, to meet the zero at some infinity. P2 to P2 to which is at infinity. Okay, so it is not necessary P1 will travel, will meet, P1, P2 will meet at this breakaway point, and P1 will move in the above, and P2 will move towards downward. That's not the case. Okay, it can either of these root locus from any of these may move upward or downward. It doesn't matter. Okay, it's not important. Okay, so one root locus will move upward, another root locus will move downward. So this is the root locus for this. Anybody, if you have any doubt, you can ask me. Take this screenshot. Problem is over. See, within I think maybe 25 within 25 minutes this problem is over. Okay, so if you people were solving along with me, it might have taken more time. Take the screenshot, all of you. Submit the homework today evening for this problem, all of you. Okay, even if you have not taken screenshot, if you have understood the concept, that is okay. Okay, you solve on your own and you submit, it is far better. Okay, it's very good if you are not taking the screenshot and if you are able to solve it and if you are able to submit it. Okay, so I want this graph sheet and the theory in your notes. Okay, so I will, as soon as this class is over, I will give you homework. You will receive the homework mail. Okay, I hope this problem is understood by you. Okay, anybody, if you have doubts, you can unmute and ask me or you can text me. Otherwise, I'll move to the next problem. Okay, I'm moving to the next problem. Okay, this is our next problem. Okay, so you have to sketch the root locus for the open loop transfer function that is given to you. So by looking at this, you can see there are no zeros. Okay, in this open loop transfer function, you can see there are no zeros, only poles are there. Okay, only poles are there. These poles are real poles, isn't it? From the this open loop transfer function itself, you can say that there are real poles. You have to find the value of k so that the damping ratio of the closed loop system is 0.5. Okay, so this is a different problem. We have not solved this model problem till now. Okay, so damping ratio zeta is given, that is 0.5. Okay, damping ratio zeta is given, that is 0.5, and you have to find the value of k here. Okay, you have to find the value of k. Okay, so let us solve these problems. So first, initially real poles, you just mention the poles. What are all the poles? Summa s equal to 0, -2 and -4. So p1 equal to 0, p2 -2, p3 is -4. Zeros are not there. So okay, I hope you have taken the screenshot while I was talking. Okay, while I was talking, you might have taken the screenshot of this problem. Okay, so I'm moving further. Okay, so look at these three poles. Okay, look at these three poles. Okay, so it is P1 equal to 0, P2 equal to -2, P3 equal to -4. Scale is 2 centimeter equal to 1 unit. Okay, 2 centimeter equal to 1 unit. I hope you have taken this screenshot. I'm moving to the next slide. Okay, so this is our problem. What is it? Okay, okay. This is not our problem. I don't know. I have a doubt something. Did I determine the k value here? That's what I want to know. Did I determine the k value? Okay, okay. I might have determined it. Okay. So yeah, this is our problem. Okay, next slide. Next slide. Okay. So you have to determine the root locus on the real axis. Take the screenshot, Amma. So you know how to determine the root locus on the real axis. Yeah. Okay, I hope you have taken the screenshot of this slide. I will move to the previous slide. Okay, so now consider a test point on the left of this P1. Look at the right side. Okay, only one pole is there. That means it is an odd number. Root locus will lie from P1 to P2. Now consider a test point here. Look at the right side. Two poles are the even number. So root locus will not lie from P2 to P3. Okay, next look, consider a test point here. Okay, on the left side. Of course, I think you people are observing the cursor. Okay, consider a test point on the left side of P3. Look at the right side. All the sum of poles and zeros is equal to 3. Okay, which is an odd number. So root locus will lie from P3 till infinity. So you have got two root locus here. One is from P1 to P2, P3 to infinity. Okay, so I will show you that. Okay, so whatever I have spoken till now is it. Okay, so take the screenshot of this slide also. Take the screenshot. I hope you have taken. I hope you have taken. I'm going to the next slide. Okay, so this is it. Okay, so this pole, of course, it is starting from the so means root locus from this pole is starting is meeting 0 at infinity. That's why I've given this arrow. Even if you won't give the arrow, at last after completing the problem, you can give the arrow mark. Even if you won't mention this arrow, it doesn't matter. Why? Because we have to determine the breakaway point and break-in points and centroid and all. Okay, so after determining all those things, you can mention the arrow of the means you can mention this arrow mark, and arrow mark means showing direction of the root locus. Okay, that's why you are mentioning the direction in which the root locus is moving. Now to show that you have mentioned this arrow marks. Even if you won't put this arrow mark here, it doesn't matter now. So I have taken scale of 2 centimeter equal to 1 unit. So two root locus from P1 to P2, P3 to infinity. Okay. So I hope this is, oh, I have taken screenshot. Meanwhile, I was talking. Okay. So I'm going to the next slide. Okay, to find the angles of the asymptotes. Okay, so here you know the asymptotic three poles are there, so three root locus will be there, and you have seen in the graph which I have shown just now. So the pole P3 was so means the root locus from P3 was meeting the 0 at infinity. So one root locus is over. Okay, so of course one asymptote was along the real axis from P3 to meet the 0 at infinity. It was traveling parallel to the root locus which has started from pole P3. Okay, similarly two more poles are there, means we have to determine two more root locus. Two more root locus means there must be two asymptotes. You have to determine the angles of two asymptotes. You need two more asymptotes. Okay, and you have to determine the angles of those two asymptotes. Okay, so in order to determine the angles of the asymptotes, the formula is 180 into 2q plus 1 by n minus 1. N equal to 3, m equal to 0. So q equal to 0, 1, 2, 3. So this is the formula. Substitute q values for different q values, determine the angles. So for different q values, so I am very, very smart. Okay, I am very, very smart. That's why. Okay, instead of writing 3, I wrote 2 there. Okay, I have to check. I have to check. Okay. Okay, so you will get these angles. Okay, so for Q2 you have got 300, so subtract 360 from this, and for Q equal to 3 you have got 420, so subtract from this, subtract 360, you will get minus 60 plus minus or plus 60 and plus or minus 60. Okay, so you have got 60 degree and 180 degree, isn't it? So, okay, 180 degree means no need to mention at all. Okay, so you have got 60 degree plus or minus 60. Okay, angles have been repeating, and you have got 180 degree. Okay, so these are all the angles. So in order to determine the centroid, sum of poles minus sum of zeros by n minus m. Okay, so now sum of poles 3 minus 0. Now sum of I'm sorry. Okay, sum of poles is 0 minus 2 minus 4. Zeros are no, nothing is there. N equal to 3 and m equal to 0. Just simplify it, you will get centroid as minus 2. Okay, now mention the centroid and asymptotes on the real axis. Okay, so I have mentioned the centroid, it is minus 2. It is exactly locating at the pole P2. Okay, we have never got such centroid till now. Okay, I have mentioned the centroid here. Okay, so I have drawn two diagrams. Okay, so 1 minute. I hope you have taken the screenshot of this slide. Okay, time is already over. Okay, very good. Okay, so you take the screenshot of this slide. I'll take the attendance quickly and take the screenshot of this slide mentioning the centroid, and in the next slide I will show you the angle of the asymptotes. Plus or minus 60, 180 degree, you need not mention the 180 degree, okay. 180 degree asymptote is not at all required. Okay, next slide. Next slide, see, plus or minus 60. So always remember in anti-clockwise from real axis positive, in clockwise from real axis is negative angle. That is anti-clockwise from real axis consider as positive, in clockwise from real axis consider as negative. So you have mentioned the asymptote. D6 పిలవలేదా? నేనేందో ఇక్కడ మీ నంబర్స్ చూస్తున్నాను, అందుకని ఏదో మిస్ చేస్తున్నట్టున్నా. చూడకుండా నార్మల్గా అయితే బాగుండేది. ఇక్కడ నంబర్ ఓకే, ఏది పిలిచాను ఏది పిలవలేదు తెలియట్లేదు. ఓకే, D8. D8 అమ్మా, నంబర్స్ ఉంటున్నాయి, పర్సన్స్ ఏం రెస్పాండ్ అవ్వట్లేదు. వై?